Hello and welcome to this new presentation in video format from ATDI. Today the focus is going to provide an overview of HTZ warfare radio planning solution dedicated to military applications. So first let's go through a quick refresh on ATDI product portfolio. In terms of radio planning, ATDI offers two main products or platforms. The first one is ICS Telecom that is dedicated to civilian applications. ICS Telecom is an all-in-one solution supporting all radio technologies deployed in the world, in the civilian world, or about to be deployed, going from analog to advanced digital broadcast, microwave links, mobile communications, satellite communications, PMR networks, and so on. The main benefit of having all-in-one solution allows users not only to plan and optimize their own network, but to analyze coexistence between services. And the second platform proposed by ATDI is HTZ Warfare. HTZ Warfare is dedicated and proposed to military entities. HTZ Warfare is a superset of ICS Telecom, meaning that it supports all civilian technologies, plus, of course, some dedicated electronic warfare functions. What we mean by electronic warfare functions is that the users are able to model the battlefield and to support functions and capabilities such as radars, direction finders, jammers, interception strategies, and so on. So that was for a refresh on the ATDI product portfolio. Now, before we go into the description of HTZ Warfare capabilities, we are going to flip through some list of references of entities ATDI is working with. Here we are presenting entities and military bodies or even civilian bodies that are currently using ATDI solutions. We are going to flip through those slides without going through every single reference, but you can make a pause on this presentation and go through the list. Here we are flipping through regulation authorities that are using ATDI's solution for both radio planning and spectrum management solutions here in Europe. Some additional references in Europe for civilian and military regulation authorities. Additional regulators on other continents in Americas, Asia, and Oceania. And again, you can make a pause on this video to go through this list. Some additional references in Africa, Middle East, and North Africa. Some references by technology, mobile operators, point-to multi-point, equipment makers that are key partners of ATDI, of course. Additional references for the broadcast world. And now some specific references of military entities that are actually using HTZ Warfare radio planning solution from ATDI supporting advanced electronic warfare functions. So you see a tremendous list of references, major references around the world. Here more focused on the United States. That is of course an important market for ATDI as well. You see some administration entities linked to military bodies that are using ATDI solution, both radio planning and spectrum management. And here some additional references with dates of engagement with major defense-related bodies in the United States. In addition, we have listed a few specific projects, some of the latest projects that are focusing on the latest technologies and issues supported by HTZ Warfare, and specifically in this case some interference and coexistence analysis between military radars, surveillance radars, and wind turbines that are significant issues for military bodies. So we invite you to make a pause on each of these slides so that you can go through the list of references that demonstrate the significant presence of ATDI with military bodies around the world. Now we are going to focus on the capabilities of HTZ warfare. Of course, HTZ warfare being a superset of ICS telecom, we also invite you to watch the video that is specifically focusing on ICS telecom and shows all the capabilities dedicated for the civilian world and technologies that of course have to be taken into account by military bodies. Now let's go through HTZ warfare capabilities. So HTZ warfare offers and boasts key functions for electronic warfare simulations, and of course you see here some keywords, but path loss analysis, handover calculations, traffic analysis, path budgets, and so on. And HTZ warfare, just like ICS telecom, integrates all the requirements supporting today's and technologies about to be rolled out, as ATDI is committed to supporting all technologies in an all-in-one solution to facilitate the life of the users as they get into new projects involving new technologies. One of the key points of HTZ warfare is on-the-move capabilities, which we use the acronym OTM, that means on the move. That basically means that not only the users are allowed to model the battlefield, but they can basically model trajectories, paths of any moving vehicle or aircraft to do dynamic analysis from a radio communication standpoint. On-the-move capabilities means, of course, that the communication electronic warfare analysis can be performed in dynamic mode, and HTZ warfare can be used as a tactical planning tool, meaning that headquarters from military bodies can basically plan a specific mission in advance. In terms of applications, HTZ warfare will allow to manage and plan communications. Control can be used by special forces for deploying specific missions, by transmission troops, frequency management services, and will allow the users to define strategies in terms of drones, UAVs, radars, direction finders, jammers, and interception strategies. Of course, one of the key input of any radio planning solution, and of course including HTZ warfare, is high-quality cartographic database. We do have another video that focuses on ATDI's cartographic capabilities. We have several options that can be provided in order to facilitate the planning for the users. Of course, cartographic databases include several layers: accurate digital terrain model, image layer, clutter or ground occupancy information. For analysis in dense urban area, a 3D building layer is required and can be provided. And another layer consists of vector files that will basically define not only roads, borders, specific areas, but more importantly, battlefield areas. In terms of formats, as there are many formats around in the market, a user with ATDI and a solution can reuse their own cartographic data, which ATDI can convert in a format that can be used by HTZ warfare. And of course, ATDI can provide specific sets of cartographic data as needed. So HTZ warfare will allow to go through spectrum management, spectrum optimization analysis, and interference analysis. So the idea is to go through occupancy and sharing of the spectrum. It will allow to go through the interference analysis and therefore the frequency assignment process and polarization assignment process. The goal, of course, is to minimize interferences in order to derive the most optimal frequency plan, which HTZ warfare allows the users to do. So then, in terms of tactical planning, military bodies have several questions in mind. In terms of, that is in direction finding, jammers, radars, typical questions are: what are the optimal locations and configuration for my radars? What's the best strategy? What's the best strategy for jamming the enemy? What's the best strategy for preventing from being jammed by the enemy? What's the efficiency of my direction finders, and so on. So those are all questions that can be answered going through radio planning process with HTZ warfare. In terms of jammers, as mentioned, best locations, optimal locations and configurations can be calculated with HTZ warfare to place jammers in order to attack an enemy network, to identify the minimum required power for jammer, and to calculate the efficiency of fixed or mobile or terrestrial aerial jammer along a specific path. In terms of interception, and there we're getting truly into tactical planning, HTZ warfare will allow to identify which elements within an enemy network can be intercepted from each waypoint along a defined trajectory or path that is predefined. And of course, countermeasures can be simulated in 2D, 3D format, and HTZ warfare can also generate not only visual reports but statistical reports in order to do risk assessment. Again, from a radar perspective, another type of object or equipment that can be supported by HTZ warfare. HTZ warfare will allow to calculate coverage of a radar, of a group-based user position radar system, or against a radar cross-section at different heights and elevations in order to derive, among other parameters, the vulnerability of a radar system and so on. So, of course, then the battlefield can be modeled in any location. It can be on-land analysis, where the user will be able to compute network coverage, to model jammers, to identify the jam links, and to derive the jammer effective area. Of course, a similar analysis can be done in the air by modeling aircraft trajectories, and analysis can be done in 3D environment. And of course, furthermore, for the Navy entities, analysis in the littoral environment can be processed as well. So truly, HTZ warfare is a tactical communication platform that will allow the military bodies to plan their network and to define the best attack or defense strategy from a radio communication standpoint. Also, some capabilities that are included in HTZ warfare are UAV path optimization, not to mention some additional aeronautical capabilities that are included in HTZ warfare, which we cover in a separate video presentation that includes specific aeronautical models, HF propagation models with dedicated modules and capabilities, as well as multilateration capabilities that allow to locate in a very accurate way any flying objects or aircraft. Again, in terms of radar, users are able to compute radar coverage at different heights of the target. radar interference, and you see here that we are showing a snapshot of a radar calculation without interference and taking into account interference and the resulting degradation. So again, what's important to mention is that HTZ warfare, just like ICS telecom for the civilian world, does support very accurate implementation of accurate models and equipment modeling. Some other capabilities that are increasingly critical for military bodies consist of taking into account wind farms that can generate false target detection for surveillance radars. And again, as presented in the list of reference and specific projects as references, ATDI has gone through extensive analysis in order to analyze the impact of the presence of wind turbines in the field onto surveillance radars. Here, just to get into more detail, ATDI with HTZ warfare offers the capability to model very accurately fields of wind turbines, which can be modeled together with the radar, surveillance radar equipment, so that multipath effects due to the reflection from wind turbine can be accurately analyzed, as well as, of course, shadow analysis, therefore resulting into accurate estimation of potential for false target appearance, which of course is a critical issue for military bodies as it triggers emergency situation without real cause. We'll see now. We are going to switch to the actual radio planning platform, HTZ warfare. HTZ warfare is a tool that can be completely configured depending on the profile of the users. So now we are going to leave this PowerPoint presentation and switch quickly to the tool. And here first a typical project in HTZ warfare or ICS telecom. Again, we invite you to watch the ICS telecom specific video presentation that highlights most of the key capabilities of the platform. We are going to go through a quick refresh here. A project in HTZ warfare is basically composed of several layers: digital cartography, digital terrain model, image layer, clutter or ground occupancy layer, building layer, vector layer for defining contours, borders, battlefield areas, parameter files that contains all the parameters defining the simulation environment, and of course network objects that contain all the equipments, base station, radars, direction finders, jammers that can be modeled in the battlefield. HTZ warfare, just like ICS telecom, features the very same import and export capabilities that allow users to implement their network manually, but setting up manually stations by importing from very basic formats such as text or ASCII file, or importing heavy quantity of data from databases. There are some 2D and 3D capabilities associated to HTZ warfare that allow some nice viewing for further visual analysis and observation. HTZ warfare, just like ICS telecom, allows path calculation between any 2 points of the battlefield area, which basically is going to show the profile between any 2 points, including the digital terrain model, clutter layer, building layer, Fresnel ellipsoid, signal attenuation curves, and so on. Then, of course, HTZ warfare allows to go through the very same network planning process as ICS telecom. supporting a wide range of propagation models, deterministic, statistical, empirical models, supporting all diffraction schemes, subpath attenuation models, impact of the climate, 3D reflection capabilities for dense urban area. HTZ warfare also allows to support indoor analysis and mixed outdoor-indoor radio planning analysis, allowing to analyze the propagation of an outdoor signal from an external network into buildings. Of course, then all type of analysis can be done, analyzing interference map coverage, traffic maps, and so forth. Then to go through interference analysis. Just like ICS Telecom, still present in HTZ warfare being a superset, is the automated frequency planning engine, traffic analysis capabilities, handover capabilities, and network planning or prospective planning, or again gap filler capabilities that allow to find the optimal location for an additional equipment in the field. What links HTZ warfare to the field, among other capabilities, is the fact that we can import measurement from drive test campaigns in order to go through the correlation process and in order to finally tune the models. As we said, one of the main capabilities of HTZ warfare is the fact that it supports on-the-move capabilities. Here we just open a very basic, simplistic example that highlights this. We have a small project with a digital terrain model in a mountainous area, the image layer as well, and let's say a user as part of a military entity is working on tactical planning and preparing a mission, and the goal is basically to make an assessment of the risks that the troops, the vehicles, and potentially the aircrafts will be taking into in such a mission. And here we have the capability to model the path, the tracks of several vehicles that are modeled here, potentially of aircrafts. We've modeled a headquarter. And the idea here will be to do a dynamic analysis with on-the-move capabilities, as you can see here, with vehicles moving along their respective paths in order to make an assessment at any point of time whether the communication between any two mobiles or vehicles and with the headquarters are preserved or not. So it's truly tactical planning in order to make some risk assessment from a radio communication standpoint. And of course, once this is again a very simple example, can involve UAVs, aircrafts, different type of equipments. This results into some visual reports and any type of statistical report that will help the decision-making process within the tactical planning organization of the military bodies. As part of HTZ warfare, what is specific in addition to the capabilities offered by ICS Telecom for civilian applications is the fact that an object in HTZ warfare can be a neutral transmitter receiver. As you can see, can be a direction finder, can be a radar, can be a microwave link, a jammer, and so forth. But you see the notion of neutral equipment, of allied equipment, enemy equipment, which means you can model completely the battlefield, taking into account allied, neutral, and enemies network in order to define the best attack or defense strategies. And of course, once you've selected an object, again, one of the key points of HTZ warfare is that it's an all-in-one solution. And as you can see, specific signal technology can be selected for different objects, and multiple technologies can be managed in a single project, which means you can analyze interference and coexistence between any two types of technologies. So the idea of this presentation was basically to provide an overview of HTZ warfare capabilities at a very general level. We invite you to watch the ICS Telecom presentation that covers a little bit more into detail all of the capabilities in terms of radio planning of ICS Telecom and HTZ warfare. We also have videos that describe ATDI's capabilities in terms of cartographic data that can be provided very easily together as a package with HTZ warfare, and will also feature additional presentations on specific capabilities, as we mentioned, aeronautical capabilities that are obviously extremely important for military bodies, but also additional presentations that will explain to more details capabilities that allow to manage radars, direction finders, jammers, and associated strategies and signal theory. So again, we thank you for participating and listening to this presentation. Of course, we remain available to address any question you may have. We have on our website, of course, a comprehensive resources, white papers, product presentations, and so forth, which can be accessed at www.atdi.com. And specific questions may be sent to sales@atdi.com, and we'll be happy to respond to your concern or questions. Again, we thank you for your attention, and we invite you to participate to other sessions with ATDI. Thank you. Bye-bye.